Reflections in parallel lines theorem. If K and M are parallel lines, then a reflection in the line K followed by a reflection in the line M is the same as a translation. So take a look at your blue line. Notice if you reflect it, you get B, which is your red line. But if you reflect it again, you get the green one. Do you notice that really from the blue one to the green one, all you would have had to do is just slide it over? So two reflections over parallel lines is the same as if you were to just translate it or slide it over. Now, two things are going to happen here. If A double prime, meaning the second reflection image of A, then A double prime is perpendicular to K and M. So what that's saying is that the line formed by connecting your image to your pre-image to your image is going to be perpendicular to the parallel lines which it was reflected over. Second of all, A double prime is 2D, where D is the distance between K and M. So here's your parallel lines. The distance in between these is this long. So the entire distance from A out to A double prime is 2 of those. So let's say the distance between K and M was 5, then the distance between A and A double prime would be 10. Example 4. Use the figure. The distance between line K and line M is 1.6 centimeters. Letter A. The pre-image is reflected in line K and then in line M. Describe a single transformation that maps the blue figure to the green figure. So we take the blue figure, we reflect it, and we get the red one. We reflect it again, and we get the green one. So the question becomes, well, how do I just get from the blue one to the green one without reflecting twice? So what we can do is we can translate, which means slide P, and then I'm going to leave a blank units to the right. So I'm going to take P, I'm going to move it, and I'm going to pull it over here, and I'm going to move it to P, or P double prime. Or I'm going to take P, and I'm going to move it, and I move it to P double prime. And the question is, well, how far are we actually going? So if the distance between K and M is 1.6, then the total distance across is double that. So if we double that, we get 3.2. So translate P 3.2 units to the right, and you'll get to P double prime. What is the relationship between PP prime and line K? So PP prime is the line right here. What is the relationship to the line K? And the relationship is they are perpendicular. And then it says explain, and we know that by the reflections in parallel lines theorem. Part C, what is the distance between P and P double prime? We already discussed that. It's double the 1.6, so 3.2 centimeters.